In many fields of science, we encounter very large or very small numbers. Well, scientific notation is a shorthand way for expressing these types of numbers. For example, the Sun is approximately 93 million miles away from Earth. That's a lot of digits as well as a lot of zeros. Well, we can shorten that by simply writing it in scientific notation form. It's 9.3 times 10 to the 7th miles away from Earth. Very small micro numbers. Viruses and germs are so small that you can't see them with the naked eye. You have to use a microscope. Well, these small numbers can also be written in scientific notation. And so for this one, we can write it as 5 times 10 to the negative 6 centimeters. Let's see how that is done. To write a number in scientific notation form, it is always going to be written as a decimal between 1 but less than 10 times 10 to some power. Now that power can be either positive or a negative. In these three examples, we are asked to write the following in scientific notation form. So we are given the numbers in standard form and asked to convert them to scientific. Remember, scientific notation form is a decimal between 1 but less than 10 times 10 to some power. That power of exponent on the 10 can be either negative or positive. So what determines that? Well, if your original number is a number less than 1, such as in the first example, then your 10 base is going to have a negative power. If your original number is greater than 1, it doesn't matter how great it is, as long as it's greater than 1, then your 10 base is going to have a positive power. All numbers less than 1, micro numbers, will have a power of a negative on the 10 base. So let's go ahead and get started with our first one. We need to write this as a decimal between 1 but less than 10. So where the decimal is now, we've got to move it. So if we move it over one place, we're still not at a decimal between 1 and 10. Move it over one more. There we are. We're at 5.71. Yes, that is a number between 1 but less than 10. You cannot move over one more because that would be 57, and that's a number that's bigger than 10. You cannot move over to 571. That's too large as well. It has to be a number between 1 and it has to be less than 10. So that would be where the decimal would be between the 5 and the 7. So let's see, how many places do we have to jump to get there? So let's see, 1, 2 places to get there. So that means our 10 base is going to have a power of negative 2, because remember, all micro numbers, any number less than 1, will have a negative exponent. So that's negative 2. My decimal is 5.71 times 10 to the negative 2 power. And there you have it in scientific notation form. In example 2, our number is greater than 1, so we're going to have a 10 base with a positive power. Let's first get it to where it is a decimal between 1 but less than 10. Where is the decimal now? Well, when you don't see a decimal in a number, it is understood to be in the back of the number. Okay? So since the decimal is here in the back, we need to move to where it is a decimal between 1 and 10. So that's 3, 6, 9 places because now we're at 2.14, and that is a number between 1 and less than 10. We don't need the zeros. We can drop the zeros. So our decimal would be 2.14 times 10 to the, and remember it took us 9 places to get there. So that's going to be 10 to the 9th power. So 2.14 times 10 to the 9th power. The next example is a micro number, which means the power of 10 base is going to be a negative exponent. So first, let's get a number between 1 but less than 10. So right now we need to keep moving that decimal over till we get that number between 1 and less than 10. So let's move over 1, 2, 3, 4 places would do it. It would be 4.7 times 10 to the, and it took us 4 places to get there. It's going to be a negative because that's a micro number. So that would be 4.7 times 10 to the negative 4 power. And so now we have converted the numbers to scientific notation form. Let's do 3 more. This time we're going to move at a little bit more faster pace now that you're a little bit familiar at how to do it. So it doesn't matter the fact that this number is a negative. When we're done, it's still going to be a negative. We just want to convert it to scientific notation form. So recall it has to be a number between 1 but less than 10. So when we move over, let's see, we're going to move 1, 2, 3, 4, 5 places. So that's going to be 6.2 times 10 to the, and is that positive 5 or negative 5? Yes, it's going to be negative 5 because it is a micro number. So scientific notation form then would be negative 6.2 times 10 to the negative 5. Next example looks like similar to one we've done, but we need to get it to where it's a decimal between 1 and less than 10. Right now, remember the decimal is in the back, so let's move to get there. 1, 2, 3 places. So that's going to be 4.7 times 10 to the 3. Is that positive or is that negative? Yes, it's going to be positive because our original number was greater than 1. So it's going to be 4.7 times 10 to the 3rd power because it took 3 places to get there. Last example, we want to get this to where it's a number between 1 but less than 10. So we're going to move over. Let's see. 1, 2, 3, 4, 5. So that's going to be 9.86. Let's drop all those zeros. Times 10 to the, and is that going to be positive or a negative 10 base power? Well, it's going to be a positive because recall this is original number is greater than 1. Anytime it starts with greater than 1, your power is going to be a positive power. So that's 9.86 times 10 to the 5th power because it took 5 places to get there. And there you have it, rewriting a number in scientific notation form. And now we're going to do the opposite. We're given the number in scientific notation form and we want to rewrite it in standard form. So keep in mind that if your 10 base power is a positive, you're going to make the number bigger and you're going to move to the right. If your 10 base is a negative, you're going to make the number smaller and you're going to move to the left. So here we have 5.2738 and our 10 base always tells us how many places we need to jump. So we're going to move 3 places to the right since it's a positive number. So from that decimal point, we move over 1, 2, 3, Whenever your decimal is sandwiched between two numbers, you keep the decimal. So your new number then, once you move your decimal into its place, would be 5273.8. And there you have it. Moving from scientific to standard. Let's do the next example. Here we have a 10 base of a negative, which means we're going to make this number smaller. So right now it's 6.45. We're going to make it into a micro number by moving 5 places to the left. So from this point, you're going to move 5 places to the left. Make sure that you fill all empty loops with zeros. So 1, 2, 3, 4, and 5. So once you fill those empty loops with zeros, your answer is as follows. And yes, it is customary to have that additional zero on the other side of the decimal sign. It doesn't change the value of it, but that's most commonly way to write micro numbers, is to include the zero there. And there you have it, converting from scientific notation form to standard form. Let's do 2 more examples. We want to convert them from scientific notation form to standard form. So recall, if your 10 base is positive, you're going to make the number bigger by moving to the right. If your 10 base exponent is negative, you're going to make the number smaller and you're going to move to the left. So let's begin here with number 3. From this decimal point, we're going to move 5 places and fill all empty loops with zeros. So 5 to the right. 1, 2, 3, 4, 5. When we do so, it's going to look like so. The number, you notice, is much bigger. It becomes 870,000. It started out with 8.7. Next example, 3.28. We're going to make this number smaller, much smaller, very, very small micro number, moving over 6 places to the left. And be sure to fill all empty loops with zeros. So when we move over to the left and fill those loops, it's going to look like so. And there you have it, rewriting numbers from scientific notation form to standard form.